Here's the situation. Your neighbor comes, frantically knocks on your door. You open up and he's saying, "Hey, listen, the LTE band B7 is the greatest. Unreal internet speeds, no lag when gaming, and the connection in fact is so fast that I can reply to emails that haven't even been sent to me yet." And you think, wow, I need this. You rush to your router, fire up Winbox and type interface LTE set LTE1 band 7. And you wait. You wait. And nothing. No connection. Is my neighbor lying? Or is my router broken? But no. We are MikroTik users. We don't take things at face value. We like to dig in deeper. And that's exactly what we're going to do in this series. We're diving deep into LTE and 5G concepts and see how they apply to the real world. So, let's talk about band locking. What is it exactly? Well, it's the process of forcing your modem to use a fixed, specific band, usually in hopes of achieving better speed or performance. But what went wrong in this case? To understand that, we need to think like a modem, or more broadly referred to as user equipment, or UE. We want to connect to a mobile network and just do our usual MikroTik things. But first, we need to figure out which base stations are around us. Fortunately, we don't need to ask. LTE base stations are constantly transmitting synchronization signals every few milliseconds. These signals help the UE detect all nearby cells. Base stations can transmit these synchronization signals on different bands. In this case, bands 3, 1 and 7 respectively. There is a threshold of signal strength that the synchronization signal must meet for the UE to consider it eligible for connection. Next, we sequentially scan the bands until we find one with a strong enough signal, in this case on band 1. This can be the first band locking strategy. We can ignore the other bands and only scan on the locked band. In this case, we couldn't lock to band 3 because of weak signal, but we could lock to either band 1 or 7 and ignore the others completely. Now that we've chosen our base station, the next step in this bachelor process, not a technical term by the way, is to learn more about our best candidate. Base stations don't just broadcast synchronization signals, they also transmit the most essential system information that the UE needs. This information is called the Master Information Block, or MIB, and Multiple System Information Blocks, or SIBs. But don't just take my word for it. Let's look at real radio signaling in Wireshark. I've captured the data exchange as my chateau attaches to the base station. Let's take a look out of curiosity what they contain. SIB1 contains the country identifier and the network identifier of the base station. But right now, the crucial part is determining from SIB1 whether we're allowed to connect to the base station. The cell barred, not barred, means that the operator has not blocked this cell. Some operators might block cells from use if they are configuring them at the moment. Cell reserved for operator use, not reserved, means that this cell is public. Some cells are private and restricted for public use. We also check the tracking area code, which serves as a unique identifier for a specific network area, to ensure it is not forbidden, such as in cases where roaming restrictions apply. We can now proceed to connecting to the base station. But how can we do that? For this, we use the Radio Resource Control Protocol. With this protocol, there are 3 stages to connect to the base station: request, setup, and setup complete. During the request stage, the UEE asks if it can connect and provides the reason for the connection. The base station then responds with a long list of configuration parameters, and finally, the UE confirms them. Let's confirm it in Wireshark. Here we can see all 3 stages. The request is relatively short. The establishment cause field shows MO signaling, which means the connection is currently for signaling only, not for actual data transfer. In the setup stage, we can see all the configuration parameters. And here in the setup complete stage, the UE confirms and lets the base station know its capabilities. So, we requested a connection, the base station accepted, and band locking has worked, right? Well, not exactly. First, the band we are trying to lock onto may not even be broadcasting synchronization signals, leaving us stuck in the search phase indefinitely. Second, once connected, we are at the network's mercy. It can reassign us to different bands. The bands the network prefers us to use can be found in SIB5. Here we can find an inter-frequency or between frequency list. These are channel identifiers that can be mapped to bands using a simple lookup table. Usually, the UE is expected to continuously measure the channel conditions upon base station's request, report the data to the base station, and switch to a better band if the network determines one is available. But do you see another trick that we can use here? Yes, by deliberately ignoring other bands and withholding measurement reports for them, we can try to influence the base station to keep us on the current band. However, the network is always 3 steps ahead in this chess game. The radio environment is highly dynamic, especially in crowded areas, and this is not always effective. Let's summarize what we've learned. When we apply band locking, we simply ignore all the other cells that aren't transmitting on the locked band. If we are lucky, we'll find the desired cell. But luck isn't a strategy. The network can still reassign us to any other band whenever it pleases. Now, let's get back to that neighbor who told you about band 7, yet you couldn't connect to it. Why? Maybe your walls are thick, and high-frequency signals don't penetrate well. Good for privacy, bad for LTE. Maybe the network is load balancing, ensuring not everyone piles onto the same band. Or maybe your neighbor just has a device with different band support. Whatever the case, the takeaway is clear. Unless you have a good reason, locking to a band is almost never a good idea. Almost like taking financial advice from the same neighbor who swears he made millions on Dogecoin. This was a longer video format than usual, so let us know if you enjoyed it, and feel free to suggest topics for future 5G and LTE videos. Until next time.